Welcome, my dear NEET warriors. Welcome to the final session of your units, dimensions, and errors. And today we are going to do all about errors and how do we combine. So this is your Captain Shreyas. Quickly smash that like button and also subscribe to the #1 NEET English channel in the country, which is your Vedantu NEET English. And quickly let me know if you guys are all ready. Get up and fired up for this amazing class. Okay, cool. So let's begin with the class, my dear warriors, and make sure you have liked the video. So let's begin. Let's first of all talk of a scientist. Is very simple that you know the world around us, around us, the world around us is so perfect, that we can't measure it accurately. We can't measure it accurately. So, probably by design or whatever you want to say, no matter how hard you try to measure anything, there will always be some uncertainty in the measurement. So, if you talk about errors in the measurement, on the in the context of measurement, errors are basically uncertainty. Errors are nothing but uncertainty in the measurement uncertainty in the measurement. Yeah, nothing can be measured accurately. Nothing can be measured accurately. There is always some kind of error in the measurement, or basically uncertainty, which I'm not sure how much is the exact value. I can give you a range of values in between which the exact value might lie. Say for example, if I ask you, what is your mass? And you reply to me, sir, my mass is 50 kg. It can't be exactly 50 kg because the measuring device which you have used might have caused some problem. Also, maybe that day you are wearing some different kind of clothing which was very heavy. Okay, sir, I will stand naked on the weighing machine. Fine. Maybe that day you ate more. Maybe that day you ate less. Who knows? So there will be some fluctuation. So what is your true body weight? Sir, can I measure the weight of a desk? Definitely you can measure the weight of a desk, because a desk is a non-living thing. It will not eat or leave anything. Sir, will that also have error? 100%, because even the measuring instrument will have some degree of inaccuracy in that measurement. So 50 kg is probably the most probable value, but there will be definitely a range of values between which range of values where the actual mass may be, where the actual measurement will be, and maybe it is somewhere between 49 point let's say 7 to 50.3 kg. So maybe somewhere in this range, I am very sure. So that surety is there, but the uncertainty is, what is the exact value? Is it 49.8, 49.9, 50, 50.1? I don't know that. So always there is some kind of doubt, but you can narrow down that doubt to a certain extent. So when you are being asked the mass, you cannot write this whole paragraph, listen brother, 50 kg is my most probable mass, but I will give you a range of values between which you can choose my mass to be. If you say like this to your brother, then he will slap you. He will be like, why are you giving me a paragraph? I just asked you your mass. So the correct mathematical or physical way to represent that is, you say 50 kg or basically 50 plus minus, there is a range of plus 3.3 and minus 0.3. So plus minus 0.3 kg. So if you give your mass like this, If you say my mass is 50 plus minus 0.3 kg, it is understood that if you subtract from 50.3, it will be 49.7. If you add 0.3, it will be 50.3. So somewhere in this range, your actual value will be. Is that understood? How we represent any value in physics, mathematics, chemistry, biology, anything, because engineers and scientists cannot measure this perfect world. It's so perfect that there is always some uncertainty in it. Is that absolutely clear? Okay, very good. Don't worry, Abhijit. Errors is confusing. Slowly it will be more clearer. Let me give you another example. Let me give you another example. If I tell you the range of my measurement, let's say the range of some value, like say distance. The range of distance is somewhere between 12.2 to 12.4 meters. The range of the distance is between 12.2 to 12.4 meters. So what is the exact distance that you would write in this particular form, the correct way, mathematical or physical way of writing it? 50 plus minus 0.3. So I can see 12.2 and 12.4 is the range. Yes, 12.2 to 12.4 is the range. So imagine 12.4 is the maximum value which it can have. 12.2 is the minimum value which it can have. This is the maximum, this is the minimum. As you can see over here, this entire thing is the range of values where I do not know where the actual distance is. The actual distance might be this, anything. Okay. So what do I, or how do I write this in terms of this correct way of representing any physical or mathematical quantity? So since this is the maximum and this is the minimum, the most probable value will be always in between. The most probable value will be in between somewhere over here. What will this value be? Quickly spam in the chat box. Exact mid number. Yeah, exact middle number. Come on, my dear students. Yes, my dear warriors. Come on, Ashish, Ravya, Abhijit, Ashwin, everyone. Come on, everyone. Yes, it will be 12 point. How much? How much? It will be 12.3. That is the exact middle value. Very good. And that will be our most probable value. That will be our most probable. That will be our most probable value. So the final answer, the manner in which I will write down the distance will be the most probable value, which is 12.3, 12.3. But remember, there is some plus minus over here, some plus minus over here. How much plus? Plus is 0.1, minus is also 0.1. Exactly on same on the both sides. Exactly. So here I'll put plus minus 0.1 meter. So that is the correct way of writing it down. Understood? So when you know that the final answer will lie between this and this, you take the midpoint, the average value, which you can call, that is the most likely value, but you cannot be for sure. So that is why probable word has been used. So that average value plus or minus some kind of uncertainty will be there. So this particular part which you are seeing over here, this is called as the uncertainty in the measurement. That is bringing in the uncertainty in the measurement, or you can also call it as the absolute error in that particular measurement. This is the absolute error or the uncertainty part in that measurement. You can never have this plus minus as 0. Okay, you can never have this plus minus as 0, because then it will be perfect, unless it's like a mathematical constant like pi and all of that. So oh, fair enough till this point. Very good, Sudarshan, Sumit, Trupti, Rishwant. Very good, Abhijit, Uma. Awesome, awesome, perfecto. So now that we understood this, how errors are being represented with a most probable value plus or minus some uncertainty in the measurement, are there different kinds of errors that we have around us? Definitely. So errors can be of different kinds. First is basically a random error. Second is basically a systematic error. Okay. And then we are also going to talk about something called as the least count error. Least count, least count error. Least count error. So what are these kind of errors that we are talking about? So let me go one by one. Starting off with systematic error. Just like the name suggests, it's because of a manner in which you are measuring it. Maybe, maybe you are always using the wrong method. Maybe the instrument is faulty. Maybe you are always doing a particular step after a certain step, which is always introducing something. Even if you change that step, something else will come, which will again cause some problem. For example, I'm measuring the distance between two cities. Okay, I'm measuring the distance between two cities. So I can say I will take a tape and I will, put it between the two cities. Guys, that is a very, very lengthy method. If I take a tape and if I put it here, then I have to again use the tape again and again and again and again in a repeated manner till I reach the other city. What if I'm not traveling in a straight line? What if I'm going in a slightly curved line? That's it. It is going to cause some problem. So definitely some error will be introduced because of the system or the procedure that you are following. Maybe it could be the faulty instrument or the procedure or the manner in which you are conducting that entire thing. So obviously you can use some better instruments, you can use some better procedures, you can use some better systems and follow those guidelines that will reduce the error. But no matter what you do, there will always be some kind of error. One student might say, sir, I'm going to take a drum and I'm going to roll that drum and I'm going to see how many times does the drum rotate. And by seeing how many times the drum rotates from point A to point B, I can measure the distance. Well, that is good enough. But again, maybe the drum might have some irregularities in the shape. It might not be perfect circular. You might not be measuring the radius correctly. Maybe the radius itself has some error because radius also needs to be measured using something. So always there will be some error no matter what you do, because radius also can't be measured perfectly. Also, till what value of pi will you use? Maybe you will use till fifth decimal, sixth decimal. So at least the seventh decimal will have some uncertainty. Is that clear? So that is basically systematic error. Least count error is basically because of the device's limitation itself. Let's say you devise the best way, best procedure, the best person you bring in to do some measurement. In spite of that, the instrument itself has its own limitation, and beyond which you cannot go and measure it more accurately. For example, you use your watch. It has tick, 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 that second hand, right? So I can measure till 1 second, 2 seconds, 3 seconds, 5 seconds, but I can never measure 1.5 seconds or 2.37 seconds or 7.85 seconds. Not possible. Because over there a tick is a second, and I cannot say, sir, I saw that second hand was somewhere in between, I remember it in my memory, it was exactly at 110 distance, so it is 2.1 seconds, sir. No, 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 that you can't do. So same way, you might have seen a weighing machine, digital weighing machine in a shopkeeper's place, or maybe at the billing counter. All right, so it might have a decimal reading till 0.1, 20.1 kg, 20.2 kg, 20.3 kg. So even if you add some more mass on it, let's say it is showing 20.3 kg. Even if you add, it will still show 20.3 until the mass exceeds some 100 grams, and then it will go to directly 20.4. If you add more mass, 20.4 will remain 20.4 until you add enough mass to make it 20.5. So again, there is a margin of error because of the limitation of the device. That is called as the least count error, or least count of the instrument causing some uncertainty in the measurement. Okay, everybody getting this point? Everybody? If you are using your normal scale, does it have a limitation? A normal scale which you use in your school, colleges, whatever, does it also have some kind of limitation? 100% it has some limitation. And if you see the centimeter scale, if you see, there are small, small divisions. Each division is a millimeter. Each division is a millimeter. So below 1 millimeter, you cannot measure using this scale. I cannot say, sir, I will measure the thickness of the hair. Sir, it is 0.007 millimeters. How did you measure, man? Oh, sir, my guess, because my eyesight is very good. You can't. This least possible measurement you can do using this scale is only 1 millimeter. You can't beyond that. Is that right? Okay. Similarly, random error. Random error is because of literally random things. Okay, so we'll come to that. Hold on. First, least count error. It's the limitation of the device. Limitation of the device, measuring device. Okay, and this is basically the smallest measurement it can make, smallest measurement which it can make. If we talk about systematic errors, it's because of the procedure, it's because of the procedure, it's because of the instruments, it's because of the instruments which are using, all right, it's because of the systems which are being followed, it's because of the systems being followed. Okay, so because of which there are systematic errors. How you are performing it? Are you using a tape to measure it? Are you using some light to measure that distance? Are you using sound to measure the distance? These are all systematic errors. Random error, you cannot predict it at all. So these are basically unpredictable. These are completely unpredictable errors. They are completely random in nature. They can be sometimes there, sometimes not there. These are usually due to external influences. External influences. For example, you are measuring, how much mass is there in this pan, but suddenly your friend was walking outside, so you did not look properly and you wrote some other reading. Random error. Okay, suddenly today was hot, so the scale expanded. Because the scale expanded, you took a different reading. Gone. Okay, so completely random, guys. You want to measure the temperature of a person, so you put the thermometer under the arm and you are measuring it. But somehow, maybe at that point of time the person was not having that much fever, or maybe the person had just drank some cold water. God knows, something had happened, so because of which the body temperature showed something different than usual, so you will get a completely different answer. So these are complete nonsensical errors which can hamper your measurement. And usually you will try to make sure that the lab with which you are measuring it, or the manner in which you are measuring it, is very apt. Maybe wind is blowing, because of which the scale flew and something happened and something else happened, and because of which you got a different value. So you will try to minimize the external influences, and you will try to be focused so that the random errors are as less as possible. Is that absolutely clear, my dear? Abhijit, clear about this? Shravya, everyone? Perfect. Sumit, Uma, Sudarshan, Trupti, Rishwant, everybody? Okay, the different kinds of errors that we have. All right, so this is more theoretical. So now let's go to another interesting concept called as accuracy and precision. This is very, very important for you to understand what is the meaning of accurate and what is the meaning of being precise. Okay, so this reminds me of a very interesting joke. And one student told me, sir, I'm very quick at calculations. You ask me any calculation, I can tell you very quickly. I was like, wow, that is so cool. Then I told, what is 517 multiplied by 625? He's like 29. I'm like, what? How did you do it? It's like, sir, I'm very fast. But I was like, wait a minute, bro. This answer is wrong. I'm asking you some big number into big number, and you're telling me this answer is 29. He's like, yes, sir. I just told you I'm very fast. Where did I tell you I'm accurate? I'm like mind blown. Awesome. Genius, bro. So basically, something very similar is accuracy and precision. Accuracy means if the actual value is something, how close you are to the actual value. That is being accurate. Being precise means if you're doing a mistake, you're always doing the same mistake. That is called as being precise. Last time also I did this, today also I'm doing it, tomorrow also I'm doing it. So, sometimes students always do this silly mistake. Every time there is a word like not, which of the following is not the answer, which of the following is not this, which of the following is not that. You always miss the word not in the examination. So every time you are doing it, you are very precise in your mistake. You're not very random in it. But being accurate means the answer was something, and maybe you are very close to the final answer. The final answer was supposed to be 29. You are getting 28.87 or 29.2, something like that. So very close to the answer. So that is a difference between accuracy and precision. And there is a very wonderful diagram to show that as well. See, this is a dart game. I'm pretty sure you would have played it at some point of time or seen it, or maybe you can imagine it now. This is a dart board, and on which you basically throw the darts, and if you hit the center, that is bullseye. So you get maximum points, right? How many of you have played it? Maybe with a gun, or maybe with an arrow, or with an actual dart. How many of you have played it? So imagine a pro, a legend, a sigma, always throwing the darts at the bullseye. And every time the person shoots or hits the target, every time is hit at the center. It is called as the bullseye, right? If you hit at the center, you get maximum points. So it's highly accurate and precise. Why accurate? Because if you're close to where your target is, then you are accurate. And precise because every time you throw, you are hitting at the bullseye. So you are very accurate and precise also. But then look at this. Look at this. This dude, this is ultra legend. This is ultra legend. Every time you throw, he is hitting here only. Some nonsense is happening. Every time he throws, he is hitting here. Precise. He is very precise. But is he accurate? No. Why? Because this bro is hitting it somewhere here. You are supposed to hit here, you are hitting it here. So this is not accurate, but 100% this is precise. So maybe for that particular bro, that ultra legend, I'll have to shift the dartboard. I know this dude is always going to hit over here, so I'll shift the dartboard and maybe then he will hit here. But you know, he's an ultra legend. If you shift the board, that dude will hit somewhere else again precisely. So something is off, okay? But this is another interesting thing. Whenever such things happens in real life for a scientist or a engineer, that is a good thing, because then they know that something is off constantly. So maybe they can deduce a law, or maybe they can find some new discovery. Oh, why is this always happening? I was expecting this, but always this is happening. So oh, maybe there is something happening in this, you know, setup, and they end up finding some new discovery or invention, right? So this is actually something to look out for. This is completely random. Look at it. Sometimes this bro is hitting here, ultra pro legend max, sometimes here, sometimes here, sometimes there. There is no consistency. So precision is not there. Second thing, there is no accuracy also. You're not even hitting the target. I mean, just like I can hire a monkey and ask the monkey to throw the darts. The monkey will throw it exactly the same way. So that is the difference between accuracy and precision. So accuracy means how close you are to the actual value, and precise means how consistent you are, how consistent how consistently you are getting the same value, how consistently you are getting the same value. So example of these things would be, for high precision, high accuracy, maybe the actual value was, let's say the actual value, let's say our actual value is example 30.0. When it is highly accurate and highly precise, then it would look something like this. Maybe it will be 29.98, then 30.03, then maybe 29.99, then 30, something like that. So when the readings are like this, 30.00, okay, then you're very close to the real value. So this is precise and this is accurate. But high precision, low accuracy would mean something like this. The real value is 30, but you are getting like 28.2, 28.2316, 28.20, okay, 28.19. So this is definitely off from the real value, but you are very close to 28.2. So, you know, very precise, but definitely not accurate as compared to the actual value. Low precision, low accuracy means something like this. The expected value, actual value is 30. You are getting 25.01, then 32.93, then you are getting 29.07, then you are also getting 36.15. What random values are these? These are not even close to some number. So, you know, they are completely off, not even accurate, not even precise. Such a question has come in JEE Mains, okay, to figure out which set of data values are accurate, not precise, etc. Is that clear? Right. Sir, your class for electric potential and capacitance one shot. Okay, for time tomorrow, first time tomorrow. I have exam. Virupaksha, I didn't understand what you mean. Uh, Abhijit, there is one more class on vernier caliper and micrometer screw gauge. That is also important. We'll do that. Okay. Okay. So fine, sir. This is also clear. What is the meaning of accuracy and precision? This is also done. So absolute error, relative error, and percentage error. Let's go one by one. So if our physical quantity, if our physical quantity has been represented as some m, and then I put plus minus delta m. This delta m is what is called as your absolute error in the measurement. Okay, absolute error in the measurement. Example, if I tell you, the distance between two places is 7 plus minus point 0.3 or let's say 0.5 meters. So 0.5 meters is the absolute error. 0.5 meters plus or minus is the absolute error. It tells me absolutely how much uncertainty is there. So it nothing but tells me the actual uncertainty in the measurement. Uncertainty in the measurement. Relative error is nothing but your absolute error, the whole thing divided by the absolute error, whole thing divided by the most likely value, the most likely value. That is basically your relative error. So it is delta m divided by m. M is the most likely value and delta m is the absolute error. So delta m by m is nothing but called as the relative error. So relative error is absolute error divided by the most likely value. Example, I tell you the time is 10 plus minus 0.1 seconds. So then the relative error is 0.1. This is the uncertainty, and most likely value is 10. So it will be nothing but 1 by 100, or you can also write it as 0.01. It's like a fraction. It's like a decimal value which I get. So it tells me as compared to the main quantity, how much fraction is there. It's also sometimes called as the fractional error also. So relative error, or sometimes also called as the fractional error. Fractional error. So when I see that the fraction is 100, I should be happy about it, because if my time is 1000, 100th of it is a small number, so I might be okay with it. 100 in a thing is okay, maybe justifiable. But if it is 1/10 or maybe 1/5, then I will be worried. I'm like, 1/5 is the error? Oh, there is something big problematic. But if it is 1000 or 1 millionth, then I will be very happy. I'm like, okay, yeah, this is very small. It is okay. I can do with it. Okay, so that is fractional error or relative error. Last one is the percentage error, because sometimes people don't like fractions. They like in percentage. If you tell how many marks you got in CBSE board exam or this board exam, and they say, I got 202 divided by 280th marks. Like, okay, wait, what is this? 202 divided by 280. Okay, is it good? Is it bad? But then you convert it into percentage. Oh, I got 90%, I got 95%, I got 85%. Then it sounds okay. Yeah, okay, fine, I got it. Out of 100, you got this much. So out of 200, you would have got this much. Out of 500, you would have got this much. So percentages are easy to understand for us. Human beings understand it very nicely. So percentage error. So basically, percentage error is nothing but your relative error multiplied by 100. That's it. You can also write it as, obviously, the absolute error, which is delta m, the whole thing divided by the most probable value, the whole thing into 100. So that is going to definitely give you the percentage error. So we can block this, obviously, and we can also block this. This is also a relative error. So just to give an example for this, the same thing which we just did, time is 10, time is basically 10 plus minus 0.1 seconds. So the error, percentage error in in time will be the absolute error, which is 0.1, the absolute error, which is 0.1, divided by the most likely value, which is 10, multiplied by 100. So as you can see, 0 cancels, this will go, so it will just become 1%. So 1% is the error. So usually the error should be 1%, 2%, 5%. Beyond that, it is bad. Usually at high precision devices, they have errors in the range of 0.1%, 0.01%, like that. So the percentage errors usually should be typically less than 5%, 6%. 10% is the maximum limit till which you can go, but 10% means you are having a very bad faulty measurement system or whatever. Okay, is this absolutely clear? Okay, but a good device should have typically less than 1%. All right. Now let's go to the least count error. Let's go to the least count error. If you remember, there were different types of error: systematic errors, random errors, and the least count errors. So least count is because of the limitation of the device or the smallest thing that you can measure. So the least count error is the smallest measurement possible, smallest measurement possible due to the limitation of the device, due to the limitation of the device that is used to measure it. Just to give you some examples, your regular watch, the regular watch has a least count of 1 second. You can't go less than 1 second, isn't it? Similarly, another example, your normal scale that you use, which is also called as your meter scale, the least count of a meter scale is a millimeter. You can't go below that, which is 0.1 centimeter. So say for example, some person measures time using watch. The person can say the time is maybe 6 seconds, or the time is 200 seconds, or the time is maybe 503 seconds. All this is fine, but the person can never ever say that the time is 6.3 seconds. This is not possible with the particular least count. You can't even say the time is 200 and 7 seconds, 200.7 seconds. You can't say that. This is not allowed. Or the time is 502.9 seconds. This is also not possible with this least count. The smallest value is only 1 second. Sir, what about over here? Same thing, guys. Like I can say the length is 2.9 centimeters. In centimeters, it is 0.1 centimeter. So 2.9 centimeters is perfectly fine. I can also say it is, let's say, 58.4 centimeters. Perfectly fine. Sir, the length is 0.6 centimeters. Is this allowed? Definitely it is allowed. But what will not be allowed? Things like this. The length is, for example, 2.96 centimeters. This is not correct. The length is, for example, 58.453 centimeters. How did you go till the third decimal when the allowed decimal is only 0.1 in the centimeter? What about this? Length is 0.6810. This is also not correct. Even writing this is not right, guys. Lot of people think, sir, what if I write 0.600? This is same as 0.6, sir, so this is fine. No, guys. See, the moment you add these extra zeros, recollect the chapter, the concept of significant figures. These zeros become significant. How the hell did we write the significant digits beyond the first decimal when the least count is only 0.1 centimeter? So these zeros have weightage over here. They are not meaningless. So if I'm writing these two extra zeros, that means I know accurately till the second decimal. But the problem is I can only go till the first decimal. I do not know till the second or the third decimal. Is this absolutely clear? Yeah. No issues, Kalumala. Stars, no issues. Uh, enjoying coaching in the Abhijit, I definitely don't think you should just watch YouTube and join in 11th and 12th. I'll tell you my story. So basically, I was in an environment of students which were very competitive in the board exams, but not so much in the, you know, other scholarship or olympiads or those kind of examinations. So in school, what happened is couple of students used to attend olympiad classes for mathematics and astronomy and all of that. And I used to do good or okay in mathematics, but not the best to my potential. So, I used to casually ask you, where are you guys going for mathematics? Because your mathematics marks are really good. My marks used to be, maybe if it is out of 100, maybe it used to be in 90s range, but they used to always get 98 and 99 and all of that. And then I understood that they were going to Olympiad classes. So, I never went to those classes, and I saw that difference in me when I entered in 11th standard, that they were already much ahead of that learning curve. And it's not that they knew mathematics only better, but in general, the analytical skills were much, much better. And I have that regret in my life that I did not get trained for Olympiads. It's not like I would have been All India rank 1 or I would have represented India. It's nothing got to do with that. But some foundation level kind of coaching, if I would have done it, I would have 100% been a much better student in 11th and 12th standard. So I generally advise my students that I'm not saying prepare for JEE or NEET. No, please don't prepare for JEE and NEET for 9th and 10th standard. That is absolutely waste of time. It's not needed also. But develop your analytical skills, develop your problem solving skills, develop your logical thinking, lateral thinking, visualization, be it sports also, be it music, do all these things. But develop yourself, develop your skill set in 9th and 10th standard. So that is what my thing would be. Don't join JEE NEET coaching. Please join something which will develop your skills. That is important. Okay. Right. All right. So moving ahead, guys. Now let's see how do we combine errors. That is the main thing now. Okay, sir. Till now, everything I understood. Now tell me, how do we combine errors? Fine. What is the meaning of combination of errors? What do I mean by combining errors, sir? See, many times you might measure something from somewhere, measure something else from somewhere, something else from somewhere, and then you all need to bring them together for some calculation. Example. I brought the desk from one shop. I brought the table from another shop. I brought the almirah from other shop, and I'm placing them one beside the other. I'm placing them all one beside the other. Just think about it. Just think about it. I'm just taking this almirah over here, then this table over here, maybe then this another desk over here. Okay. And I tell that, listen, this particular thing is probably 2 plus minus 0.1 meter. This thing maybe is 3 plus minus 0.2 meter. This thing maybe is 1 plus minus 0.3 meter. So now if I ask you, what is the total length when I'm placing them together? So what is the total length? So here what I'm doing is I'm adding those quantities who themselves have some uncertainty in their measurement. So essentially what I'm trying to do over here is 2 plus minus 0.1, then I have 3 plus minus 0.2, then I have 1 plus minus 0.3 over here. Now I have to do the addition of all of them. So let's put a bar over here. I have to add all of them. When you have to add, just simply add, don't break your head. So 2 plus 3 is 5, 5 plus 1 is 6. So over here you should get 6. Then you put plus minus. The absolute errors also, you just add them. 0.1 plus 0.2 is 0.3. 0.3 plus 0.3 is also 0.6. Okay, by coincidence, this became 6 plus minus 0.6 meters. So that is the answer for this. So the total length will be 6 plus minus 0.6. So If I'm designing a room, maybe I'm an architect, I will think, oh, it is 6 plus minus 0.6. So maximum value can be 6.6. Minimum value will be 5.4. So when I'm designing, I'll be careful. At least, that much 6.6 meters have to be kept. Worst case scenario. I don't know, because, that is the range of values that can come up. Is this absolutely clear? Yeah. Tomorrow chapter electric potential and capacitance I watched last week. Yes, Virupaksha, you can definitely watch my last year's Roar series, or if you want small lecture by lecture, then you can go for the Nurture Pathfinder series. Pathfinder, I think, is for 12th and Nurture was for 11th that time. Yeah. Great. Perfecto. Perfect. Now, here the rule is during addition, you are just going to add the absolute errors. So for addition, so for addition, you are just going to basically add the absolute errors. Add the absolute errors. That is the idea behind it. Okay, always add. But then comes the problem when you have to subtract. Say for example, there is some bag full of rice. Bag full of rice. From that, I take away some rice. So some amount will be left out. So some amount will be left out. So I'm taking it away. I take away some amount. How much amount I take away? Maybe 3 plus minus 0.5 kg. Okay. Or I will give you some another number so that we can understand it. Let's say I take away 40 plus minus 2 kg. And this rice bag was already, let's say, 100 plus minus 4 kg. Okay, or let's say 100 plus minus 5 kg. Chumma, some random numbers I have taken. So now what I want to do, from 100 plus minus 5 kgs, I want to take away 40 plus minus 2 kg. And I want to see how much will be remaining after I subtract. Over here, we were adding all of them. Now, for subtraction, keep in mind, whatever this most probable value is, just do the normal subtraction, meaning 100 minus 40, that is basically 60. 100 minus 40, that is basically 60. But here, plus minus, be little bit careful. Can you guess what the answer should be? Yeah, Varun, these are our PAVM 11th standard students who are just entered from 10th standard to 11th standard. Yeah, these are proper JEE Advanced classes right from the basics. If you want me to start directly from JEE Advanced, then I think half the people will, not half, 99.99% of the students will run away. Okay, so that is not correct way of teaching. Whenever you teach, you should start from the basics, isn't it? Yeah. This is the crux of the problem. You should never subtract. You should always add. So very important. So for subtraction, always add the absolute errors. Add the absolute errors. A lot of you might be thinking, sir, why should we not subtract? Why should we add? See, think what will be the worst possible scenario. Okay, worst possible scenario. Just imagine we had 105 kilos, that's the maximum value possible, or the least is 95 kilos. So from that, I need to subtract something and I will get something over here. So when can I get maximum amount left and when can I get minimum amount left? When will maximum rice be left, or whatever the quantity was here? Okay, or when will the minimum thing be left over here? Just think like that. So if I want a lot of stuff to be left, so from a large number, I will subtract a smaller number. What is the smaller number? 40 minus 2, which is nothing but 38. Then whatever is left is the maximum value. But if I want least quantity to be left, then from a smaller number, I will take out a bigger number, which is nothing but 42. Are you able to understand me? Everybody with me on this? Everybody with me on this? Yes or no? Perfect. So what will be left out over here, my dear students? 105 minus 38. Come on. How much will it be? How much will it be? Yes. How much will it be? Come on, my dear students. Yes, it will be 67. And how much will this be? And how much will this be? 95 minus 42. It will be 50. 50. How much? 50. How much? Come on, my dear students. Quickly. Yeah, very good. It will be 53. Very good. Awesome. 53. So 67 and 53. So this is the maximum value which can be left. This is the least value which can be left. So if you ask me, this is exactly 60 plus minus 7. 5 plus 2 is 7. You can see that. 60 plus minus 7. Exactly what we want. So that is why you should always add the absolute errors. Never ever subtract them. Never ever subtract them. Clear? Understood? This was subtraction of errors. Let me do some more questions so that you guys get a more hang of it. Example 20.00 plus minus 0.02 plus 3.0 plus minus 0.1. 51.00 plus minus 0.03. Okay, these are the numbers which you need to add. Let's see what will your answer be. Next, 35.2 plus minus 0.1 minus 20.1 plus minus 20.1, sorry, 1 0 plus minus 0.20. What will your answer be? Okay, let's see if you can give the correct answer for this. Maybe I'll put 40 over here. Okay. Now think and tell me what will be the final answer. Okay. Over here. This is addition. This is subtraction. First, what you will do, just do the normal addition like you would do. So this is 0. This is also 0, decimal, 0, 3 and 1, which is 4, 2 plus 5, which is 74, plus minus. This is 2 plus 3, which is basically 5. This is just 1 over here. This is just decimal and this is 0. So 0.15. Till this point, just check it out. Yeah. 84.0. 84. How 84? 2 plus 5 is 7. Not 84. It is 74. Abhijit, just check it out. Yeah, Shravya, 74. Perfect. And if I do it over here, just do the normal addition. 0 plus 0 is 0. 2 plus 4 is 6. 5 plus 0 is 5. 3 plus 2 is basically 5. So 55.60 plus minus 0 is there. 1 plus 2 is 3. And there is 0.30. Lot of this. Just check it out. I hope you guys are getting it till this point. 74.00 plus minus 0.15 and 55.60, 0.30. But this is not the final answer. This will be there in the options. And this is where many students will make a mistake. These kind of questions in JEE Mains and Advanced will suck away all your marks. Trust me, this might not be a solo question, but maybe it's a part of a bigger problem. And your final answer will depend on how accurately and how properly you are following the procedure. So the same rule also has to be applied over here. The decimal places are 2, 1 and 2. So be very mindful about it. So 2 decimal places, 1 decimal place, and here also 2 decimal place. The least is this. So the final answer should also have 1 decimal place only. So we have to round it off. Yes. So we have to round off to the final nearest number. So this will be 74.0 plus minus 0.15. When the digit ends with 5, make the previous digit even. So 10 or 20. Guys, 2 is even. So basically, because this is that number 5, the moment the last digit is 5, the previous digit, because it is odd, you add +1 to it. You add +1 to it, isn't it? So that is the reason why this will become 0.2. So this is the correct answer. So this is the correct answer. Is that clear, guys? 74.0, not even one extra decimal, and 0.2. So the least of the decimals have to be taken for addition or even for subtraction. Yeah. Yeah. Yes, that 0 has a meaning. If you miss, even see guys, 74 and 74.00, there is a lot of difference. Value wise, they are same, but in physics, this is more accurate, this is less accurate. There was a question like this once. Which of the following is more accurate? The one with more decimals, even though they are zeros, signify that you have taken that pain and that effort to calculate it till the third decimal. By chance, it came out to be 0. So, that is perfectly accurate measurement. More the decimals, less the decimals, lesser accuracy. Is this understood, my dear? All right. What about this? I can see one decimal here, two decimals here. So one decimal is basically the least. So final answer also should have one decimal. 55.60. You are going to round it off. You are going to round it off. Yes, it will be just 55.6. You don't have to do anything else over here, just by luck. But say for example, this was not like this. Let's say it was something else. Let's say it was 4 3. Then the final answer would have been 3 over here, and this will be 6. Now you need to round it off. So it will be 55 point. This 3 is lesser than 5. So just keep the previous digit as it is. So it will be 55.6 plus minus. This is 0.30. So just get rid of that 0. It will just become 0.3. So that will be correct. But let us just say this was not 0.2. Let's say this was something else. Let's say this was 0.25 or something. Then you will have to get rid of that. Got it? But right now this is just 0. So I'm just going to keep it as 0.3 only. Get rid of that second decimal. These are our final correct answers, not this. If you see it in the option, that will give you negative marks. Many students will forget the rounding off. Okay? Clear till this point? Yep, perfecto. Shall we go ahead, my dear students, to the next? Now, many times it will happen. Okay. One second. This. You have to find the. Just get this slide. You will have to find the average of the values, and this kind of question is one of the most common kind of questions which can come in the examination, where many values are given and you have to find what is the absolute errors, percentage error, relative error, etc. So how to find errors for multiple measurements. This is also very commonly asked. For multiple measurements, what to do? Let's say there is a student who measures some value to be V1, but there is some degree of uncertainty in it, which we do not know yet. But we are just chumma saying, okay, listen, this is the value V1 which I'm getting. I do not know the uncertainty in the measurement for now. Other student, that's why we take multiple values, because we do not know the uncertainty. We ask another student, hey, come on, do this, measure the value. He measures the value to be V2. Another student will measure the value to be V3. Like that, we take multiple readings. You might have seen this in your labs or in your practical classes also. The teacher will not trust you alone. They will ask, hey, a group of 5 students, everybody measure it independently. Don't talk to each other, and independently you give me the values. We will take the average of the readings. Why that average is taken? Because you don't trust the people, or you are not really sure who has done a mistake, or might be some random errors would have kicked in. So that is why we end up taking the averages, or the means. So basically over here, all these are independent independent readings or measurements, independent readings which are being measured. So in order to get there, first thing that we need to do, the first thing that we need to do is take the average of it. So this is also called as the mean value, the mean value, which will be simply put V1 plus V2 like that till Vn, the whole thing divided by the number of readings. The mean value often is represented with a symbol like this. The triangular brackets represent average. So keep this in mind. You might have written average velocity, average acceleration like this, A average. You can also write it like this. So this is basically the symbol of average, the symbol of average in mathematics, physics, chemistry. Okay. So this is the symbol, the triangular brackets, whatever you write, that means average. So if I write like this, it means, tell me what is the average value of the force. Average value of the force. So whatever is in the triangular brackets means the average of it. So first thing you will find is the average value. The next thing that you will do after finding the average is subtract the average with each one of these. V1 minus the average value, V2 minus the average value, like that. Okay, keep on doing that. Keep on doing that. You will basically get the error or the deviation of each quantity from the mean. So delta V1, delta 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 means the difference, or basically the change, or basically the variation, you can say variation, change, variation, difference, etc. So for every single measurement, how much are you differing from the average value? So this minus this will be nothing but delta V2, and so on and so forth. This will be basically delta Vn. This will be basically delta Vn. So do that for all the readings. Do that basically for all the readings one by one. But some value might be more, some value might be less than the average value. So these deltas could be positives or negatives. So that is why we will take the modulus. That is why we'll take the mod, because we don't want the positive and negative sign. So these are called absolute errors. Absolute errors. Mod, because of that the word absolute has come. Errors, that means how much are you varying, how much are you differing from the average value which you are expecting. Once you do that, just you just have to once you do that, you just have to basically take the average of these values. Yes, this is then called as the mean of the absolute errors. Mean of the absolute errors. This was just the mean. This is the mean of the absolute errors. So it will be mod delta V1 plus mod delta V2, like that till the last number mod delta Vn, the whole thing divided by the number. That is the mean absolute errors. So the symbol for that will be, you are taking the change, or basically the errors, so delta V, mod of that, and then I'll put triangular brackets. So delta is the difference, mod is absolute, and the triangular brackets signify the average or the mean value. So the mean of the absolute errors. Triangle for the word mean, mod symbol for absolute, error for that delta. Mean of those absolute errors, that will be the symbol for it. That's it. So then our final answer will be this particular mean value, which is nothing but delta V, and then I will put over here plus or minus this thing, plus or minus this particular thing. So that would be our final answer. We will do a question on this so that you guys get an idea. Okay, let's do a question on this so that you guys get an idea. Ansika, dot product, vector product is there next lecture or next chapter, I would say, because that's under vectors. Today we are doing units and dimensions. Okay, don't get confused. Yeah, right, right, great. All right. Shall we do? Shall we do a question? Shall we do a question, my dear students? Let's do. Let's do a question. Here are the values. The values, the values of an experiment are as follows. Are as follows. Let's say it is the number 12, then the number 11, then the number 8, then the number, let's say the number 7, and let's say the number 10. These are the values which a person has got after multiple readings. Okay. And the question is, find the final answer that you should be getting. Okay. There are 4 readings which you have taken for an experiment. What will be the first thing that you will do, my dear students? First thing, you will find the mean value. So you will find the mean value, average value. So just add them up. 12 plus 11 plus 7 plus 10. The whole thing divided by the number 4. Okay. How much will it be, guys? Come on, do the math. 12 plus 11 plus 7 plus 10. Yes, it's not a difficult thing. 12 plus 11, 23. 23 plus 7, 30. 30 plus 10, 40. 40 divided by 4 is basically 10. So that should be the number 10. So that is basically the mean value. This is nothing but the mean value of the reading, average value of the reading. The next step of the procedure, will be taking this and subtracting it with this number, mean value. So 12 minus 10, 11 minus 10, 7 minus 10, 10 minus 10. But whatever answer you get, yeah, just take the mod of that. So 12 minus 10 is basically 2, but you have to take the mod of that. That is 2. Then again, 11 minus 10, what is it? You are just going to take 1. 7 minus 10 is minus 3, is basically minus 3. Minus 3 is modulus, is basically the number 3. 10 minus 10 is basically 0. Always take the mod values. Okay, so we have found out the absolute errors. Absolute errors have been now found out. What is the next step after finding the absolute errors? What is the next step after finding the absolute errors? You have to find the average of these values. So you have to find the average of these absolute errors. So 2, and then you have 1, and then 3, and then 0, whole thing divided by 4. What is it coming out to be? 2 plus 1, 3, 3 plus 3 is 6, 6 by 4, 6 divided by 4, which is 3 by 2, which is 1.5, which is 1.5, isn't it? So what will be my final answer? What will be my final answer? Important thing, guys. Oops, what is this? Can I move this? Okay. Okay. So what will be my final answer? A lot of you are going to say, sir, the final answer is very simple. It is going to be nothing but 10, 10, and then you are going to put plus or minus 1.5. But this is not correct. Can you identify the mistake in this? This answer is not correct, guys. There is some problem in this answer. Can you guys quickly identify where the mistake has been performed? There is a small mistake in this. There is a small mistake in this. The mistake is, how the hell did we write this decimal place? Because there was no decimal place anywhere. So the uncertainty in the measurement was only till the integer part. Yeah, be careful, guys. So this is not going to be 1.5. You need to round this off. Yep, you need to round this off. Yeah, this number 5 which you see over here. Yeah, this number 5, this decimal place cannot come. So because it is 5, the previous digit being odd, you add 1 to it. You add 1 to it, and that is why it will just become 2. Don't even put 2.0. That 0 is having significance if you put it. It should not be there. Only the proper natural numbers or integers should be there. Decimal places cannot be there because it is not there. In addition and subtraction, the least of the decimal places should be counted. So why was this rounding off done? Because the least of the decimal place, least of the decimal places, least of the decimal places during addition or subtraction. So here the decimal places was none. So there is no decimal place over here. No decimal places. No decimal places. So final answer cannot have decimal places. So hence it will be 10 plus minus 2. This is the right answer, guys. Answer will be 10 plus minus. Understood why rounding off we have learned, why significant figures and decimal places we have learned for this day. Because when you get questions like this, many students will leave plus minus 0.5, 1.5. They will get negative 1 marks. Negative marking is there, right? But you guys, you know the rules. You will get full marks, plus 4. Yeah. Yeah, definitely, William. I'm so glad that previous lecture was useful, and you can see the direct application of the last year's last topics lecture, concepts right over here. Okay, perfect, guys. So now that you have understood how do we deal with multiple values, I have just shown you the in general formula also, and I have shown you one practical demonstration. The questions are very simple, guys. You might get 5 values or 6 values, not more than that. uh, unless they want to torture you, which they have never done that till date. They will not give you some 1,000 values and say, oh, find the average. That will be torture. That will not happen, don't worry. But there is one very interesting thing which I want to show you regarding this method of averages, and this is going to blow up your mind. And tell me if I was right or wrong about this, because whatever answer you are going to get after this will probably, yeah, give you a lot of killer motivation. I'm like, wow, sir, that wow feeling is going to come after this question. Okay, so let's talk about this. Imagine there is a student one, student number one. He measures, he measures a brick. He measures a brick, okay, using, or he measures a brick um, using a scale of least count equal to 0.1 centimeter. Okay, 0.1 centimeter. And he measures that the length of that particular brick is, he measures the length of the brick is, let's say, 20 point, let's say, 1 centimeters. He measures the length of the brick to be example, or let's say just 20 centimeters, 20.0 centimeters. Chumma have told you. Okay. Another student is there. Another student is there. Student number 2 uses same instrument, but he ends up measuring, he measures 10 bricks. He measures the length of 10 bricks, and he finds the length of the complete set of 10 bricks to be 202.0 centimeters. 202.0 centimeters. Okay, very interesting scenarios. One student is using an instrument, measures this length. Another student measures the length of 10 bricks using the same instrument. Who has more absolute error? Quickly answer in the chat box right away, right now. Absolute error, absolute error, absolute error is more for or less for student number 1 or student number 2? Come on, quickly let me know in the chat box. Absolute error, is it more or less equal to for student 1 or 2? William, the Telegram notes not needed. The notes will be pinned in the comment section or in the description box of this video. Just like in the previous video, you can see session PDF link will be there. So you just need to log in through Vedantu. If you don't have an account, create a free account. It's very simple. Okay. Session PDF link will be there in the comments or in the description. Yeah. Girish saying student number 1. Is that so? I don't think so. I'll tell you, student 1 and student 2 both have the same absolute error. If you ask me what the absolute error is, the absolute error is basically the first decimal place, 0.1, which is exactly the least count. So the smallest measurement was 0.1. So you can measure 20.1, 20.2, 20.3, 20.4 like that, but you can't measure 20.45, 20.47. Second decimal measurement is not allowed because of the limitation, least count. So absolute error is the uncertainty in the measurement. So if student 1 has to tell the reading, student 1's reading, it will be technically 20.0 plus minus 0.1 centimeter. If you ask me student number 2's reading, it will be nothing but, it will be nothing but 202.0 plus minus zero point 0.1 centimeter. So both the readings have the same absolute error in whatever they have measured. Whatever they have measured. Okay, same scale, same instrument, same absolute errors. Okay, is that now clear, Abhijit? Especially after writing it like this, it would be very clear. So the student number 2 also measured the total length to be 202.0. Absolute error was 0.1 in the total measurement I'm talking about. Is that now clear, everyone? But there is a catch. The moment you go for per brick, who is more accurate, things start becoming slightly different. So let's go per brick. Now the first student has measured 1 brick only. This guy has measured 10 bricks. So very important, the length of 10 length of 10 bricks is 202.0 plus minus 0.1 centimeters. Therefore, the length of a brick will be how much? Just think about it, because this will be length number 1, each length of a brick plus minus delta L. Then length of the other brick plus minus delta L. All the bricks are identical. Like that, you will have it 10 number of times. You are basically adding. It's basically addition of errors. If you see, this is nothing but addition of errors. This is nothing but addition of errors. 202, you got it by adding the lengths of each brick. So this thing will be nothing but 202.0, the whole thing divided by the number 10, plus minus 0.1, the whole thing divided by the 10 centimeters. This would be how much, guys? This will be 20.2 plus minus 0.01 centimeters. Suddenly a magic has happened. But he did for 10 bricks and he got the error as student 1. Yes, Abhijit, I'm coming to that point. That is where the wow factor is. So when the second student measures the length of a brick, the funny part is he ends up getting till second decimal. That means he is more accurate than the first student. Even though both the students use the same setup, same measurement device, the method of averages suddenly helps us improve the accuracy. So this reading 100% is more accurate than of student number 1 because of the second decimal place. But this is not the right way of leaving the answer, because I have gone till second decimal place. Technically I should put 20.20, okay, because there were 4 significant figures here. So technically this should be 20.20, okay, 4 significant figures over here. So same thing I have continued over here. Is that clear, everyone? Did you understand how method of averages improves the accuracy? And if you measure per quantity now, obviously now it looks like this guy, student number 2, has better absolute error than this guy. This has more absolute error. This guy has lesser absolute error, right? So as compared to the first student. Everyone understood? Was there a wow? Yeah? Are you able to digest this? Let me know quickly in the chat box by putting up some heart or some fire. Girish, yes, we will be doing PYQs also. Yeah, you will be seeing PYQs also now. Fair enough, sir. Now I understood why averages are important and why, we did all of these things, averages. Okay. Now let's go to the final part where you have to multiply or divide, or even let's say take the powers of a quantity of where things are being raised to something. See, examples of this: kinetic energy is half mv square. Mass has some error, speed has some error. Obviously, kinetic energy will have some uncertainty. Distance is speed into time. Speed has some error, time has some error. So, distance will also have some error. So, how to do such things? How to do such things? Right. See, for doing the calculations of errors for anything which is multiplied, divided, or even things raised to some power, like half mv square, v is raised to some power. If our physical quantity, final physical quantity, is some constant multiplied by physical quantity 1 raised to alpha, physical quantity 2 raised to beta, and so on and so forth, then the relative error, which is delta p by p, will be, forget the constant, relative error in the first quantity, relative error in the second quantity, relative error in the third quantity, so on and so forth. You need to keep adding it. It will keep going like this. But take the power, put it over here with the mod symbol. Take this power with the mod symbol and keep on doing that. That is what the final answer will look like. Now, if I give you this formula, 100% you will not be understanding it. Sir, what have you exactly done? Please show me. Demo. Give me a demo. Don't worry. I will make you understand with a live example over here, but this is the formula. The relative error in the final quantity will be the modulus of the power multiplied by relative errors of each quantities. Add them up. That will be the final relative error. Shravya, see, in the previous problem, what we just did, I just told you, both the students use the same instrument. One student used it for measuring only one brick, other student measured the length of 10 bricks. Absolute errors for the total measurement was same. But when you find it per quantity, per brick, then things will be not the same, because when it is 202.0, the total length of 10 bricks, if you measure it per brick, 202 will be divided by 10, which will be 20.2. Slightly more accurate. Maybe this was the actual reading. Maybe this student has made some error over here. And 0.1 divided by 10, that will make it 0.01 centimeter. So, when you are seeing it per brick, the absolute error by student 2, the absolute error by the student 2 is no longer 0.1, rather it is 0.01. So it is definitely smaller than student number 1. So this is more accurate as compared to student 1. So whenever you take average, yes, that error is there in the total quantity. So that error will now get divided per quantity. So the absolute error reduces per quantity. Because when you are measuring for 10, 15, 20, 100 items, that same error is there for the total items. So when you try to find it per quantity, that error will also get divided. So which means you will be more accurate. Clear now, Shravya? I hope this is absolutely fine. So let's do a question on these things so that you guys get an idea. So for example, say for example, I write down example, distance is speed multiplied by time, which is also v raised to 1 into t raised to 1. And I tell you, listen, speed is 20 plus minus 1 and time is 100 plus minus 2. Chumma some example I have taken. Question is find the distance. Question is find the distance. As you can see, speed has some error, time also has some error. So distance will also be having some uncertainty in it. First, let's see, distance is v raised to 1, t raised to 1. Why did I write it like that? Because our formula demanded something raised to something. Always write it with the physical quantity raised to the suitable power. If there is nothing, you can always put 1. Okay, now what do we do? Now, the relative error, in distance, very, very important, will be relative error in speed plus relative error in time, the powers will come over here, modulus of 1, modulus of 1. Okay, so it is basically nothing but delta V by V plus delta T by T. Okay. Now, what is delta V? Delta V means the error in the velocity, which is 1. What is the most likely velocity? It is nothing but 20. What is delta T? It is nothing but 2. What is T? Most probable value, which is basically 100. So, what is this going to be? 1 by 20, 1 by 20 plus, if you want, we can take the LCM. We can take the LCM, that will be better. The common denominator can be 100. So this will become 5 plus 2. So therefore, delta D divided by D will be nothing but 7 divided by 100. So the relative error in distance is 7 by 100. The relative error in distance is 7 by 100. If you ask me the error, percentage error in the distance, just have to take 7 by 100, 7 by 100 multiplied by 100. That's it. So that will give me 7% error. So the final error is basically 7%. Is that clear? But sir, what will the final distance be like if you put it in plus minus something? Well, that also we can. Just say this. If you talk about this d over here, that d is v into t. That d is that velocity multiplied by time. Velocity is nothing but 20, most probable. Time most probable is 100. So it will be nothing but 2000. D will be nothing but 2000. So if you substitute it over here, it will be delta D divided by 2000. Delta D divided by 2000 is 7 by 100. 0, 0, 0, 0 cancels. So delta D will be 7 into 20, which is nothing but 140, which will be nothing but 140. Hence, our final answer distance will be, most likely the distance is 2000. Most likely the distance is 2000, but plus minus, I should put 140. Plus minus 140. So that's how you can take care of multiplication. Very easy, simple. Yeah, clear at this point. Start by expressing it in powers, then take the powers with the mod value, multiply it with the relative errors, start substituting those absolute errors over here and the most likely values over here. You will get percentage or relative error. But if you actually want the answer, then find the most probable final quantity. Using this, you can easily get the answer. Let's do one more question so that you guys get a hang of it. Don't worry, guys. Yeah, let's do one more question coming up on your screen. Here it is. Let's say the question is like this. The mass of something is 50 plus minus 0.5. Okay, and let's say the volume of that thing is 10 plus minus 0.1. Can you find the density? Can you find the density? Obviously, this will definitely involve division now, as you can see, density because density is mass by volume. But to write it in powers, it will be m raised to 1, volume raised to minus 1. M raised to 1, volume raised to minus 1. So using the formula of errors, whenever you can write it in some constant into power this, power that, etc., immediately you can write that the relative error in density, final quantity, will be relative error in mass, take the power, take the mod value, plus relative error in volume, take the power but the modulus of it. So this will become nothing but delta m by m plus delta v by v. Okay. So delta rho by rho is equal to, what is delta m? Error in the mass is basically 0.5. Most likely mass is 50 plus error in volume 0.1. Most probable answer of volume 10. Okay. So this will be nothing but 0.5 by 50 is nothing but 0.01, and this is also 0.01 only. So this will be nothing but 0.02. If you ask me the percentage error in density, the answer will be 0.02 multiplied by 100. So that is going to give me 2% of error. So 2% of error is there in the final answer. But if you ask me what is the answer of density, well, then I will go over here. Yeah, the error in the density I don't know, but can I find the actual density value? Right, definitely from here. Most likely mass is 50, most likely volume is 10, so that is going to be 5. That is going to be 5. So instead of density, put the number 5 over here. This is nothing but 0.02. So therefore, delta rho will be 0.02 multiplied by 5, which is 2 5s are 10, right? So 2 5s are 10. So this is just going to become 0.1. So the final answer of density, will be, most likely it is 5, but plus minus 0.1. 5 plus minus 0.1, but to make sure that it is consistent with our significant figures and decimals, so 5.0 plus minus 0.1, that is the answer. Density is 5.0 plus minus 0.1. Is this absolutely clear, guys? Akshay, now did you understand? Just check it, Shravya. So the concept is, whenever you can express any physical quantity in this form, or rather try to express the physical quantity in this form, then you can directly use this formula of relative errors. Powers modulus multiplied by relative error, add them. That will give you the total relative error in the physical quantity. Now distance was speed into time. So try to make it into that form. How? Speed raised to 1, time raised to 1. Oh, so 1 will come outside and this one will also come outside, relative error of speed and time. Delta V means error in velocity. Delta T means error in time. T and V means most likely values. Those most likely values can be exactly used to find the actual distance, most likely. So V into T, which means 20 into 100. Solve it, you will get some fractional error or relative error. If you multiply by 100, percentage error. If you want to find the value of delta D, substitute this D over here, you will get delta D from this. So that way you can write most likely it is 2000 plus minus delta error, which is 140. Same thing over here. When it was division, what we did, we took the denominator quantity in the numerator with a negative power, but always take the mod of those powers. So once I get this, substitute the individual values. Is that okay, Akshay? Yes, perfect. Let's do more questions, don't worry. But sir, can you do some quantities which are not multiplication and division exactly, but something like that? Say for example, let's say for example, I tell you, kinetic energy is half mv square. Kinetic energy is half mv square. Now, what I can do over here, I'll tell you, I can just write it as, kinetic energy is half is a constant multiplied by m raised to 1 into v raised to 2. And then what I will do, relative error in kinetic energy is constants never ever considered, because I just showed you the formula. Never ever worry about the constants. They are not even coming in the formula. Just write down over here mass relative error. Okay. Power is 1 plus power is 2 and velocity relative error. That's it. That is the answer. So it will be nothing but delta m by m plus 2 times delta v by v. So say for example, it was given that the mass has 1% error and the velocity has 3% error. Then can you find the kinetic energy error? Can you find the kinetic energy? How much percentage error is there? Well, if you go over here, if you go to this particular thing, just multiply by 100, what will it look like? Delta k by k multiplied by 100 is equal to delta m by m multiplied by 100 plus 2 times the delta v by v multiplied by 100. This is nothing but percentage error of mass. Percentage error of mass is 1%. This is nothing but 2 times error of velocity, which is 2 into 3%. Delta v by v into 100 is percentage error of velocity. So that number 2 has to be multiplied. So 2 3s are 6, 6 plus 1 is 7. So 7% error is there in kinetic energy. So percentage error in kinetic energy is 7%. So if the percentage errors are given directly, you can do the problem very, very easily. Okay, I hope this is clear. Syed, there are, if I'm not wrong, 2 to 3 teachers. For now, I think there are 2 teachers only. But if at all additional support is required to complete the syllabus on time, we will take help of 3. For now, it is only Diksha ma'am and Pahul sir. Yeah, it's 2 teachers only as of now. Okay, let me give you one more example, guys, so that will make things even more clear. Say I tell you that the time period of a pendulum is 2 pi root L by G. Length has an error of 0.4% and G has an error of 0.2%. Can you find the time period, how much error percentage it has? How much percentage error it has? Let's try to do this question, my dear students. This has got something to do with the roots. Again, try to express this in power form. So this I can write it as T is 2 pi, L's power is half, G's power is negative half. Just check this out if you are accepting this. L's power is positive half, G is below, so negative half power, root means half power. Correct? Okay. So constants do not matter, never ever bother about it. So relative error in the time will be, forget about the constant, relative error of the length, relative error of G, and take the powers modulus value. So half modulus minus half also modulus. So this will become delta L by L, but this is half times, and this is also delta G by G, also half times. This was just relative error, but I can also convert it into percentage error. I can say delta T by T percentage, put percentage symbol everywhere, half times delta L by L percentage plus half times delta G by G percentage. Everything is in percentage. So half times percentage error in length is 0.4%. Percentage error in gravity is 0.2%. 0.2%. Okay. 0.4 by 2 is 0.2%. 0.2 by 2 is 0.1%. 0.2 plus 0.1 is 0.3%. So the percentage error in the time is 0.3%. Percentage error in time is 0.3%. That's how you can solve any question, whether it has got roots, whether it has got some powers, whether it is some division over here, or whether it is some kind of multiplication. Everything you can use this formula. But keep in mind, there is only one catch. This is only applicable only when the relative or percentage errors are small, typically less than 10% error. Less than 10%, you can use this. Okay, 5%, 6%, 0.5%, 0.7%. Okay, but more than that, you have to do something else. What is that something else? We can see from problem to problem. Okay, I'll show you that kind of question also. But is this clear? Let's do some questions so that you guys get an idea of it. Okay, let's see. A body travels some distance in some time. Find the velocity with some error limits. Find the velocity with some error limits. Yes, there are questions like this exactly asked in J. I'll show you the next question. I think it is asked in J. Okay. Distance is given, time is given, velocity with these error limits. First of all, velocity. Velocity is nothing but distance by time. Most likely distance is 13.8. Most likely time is 4.0. First, figure out this particular answer and then go to this. Technically, V will be D is the power 1. Time is raised to the power negative 1. So, relative error in velocity will be 1 time delta D by D plus also negative 1's modulus into delta t by t. Now, delta v by v will be delta d, you already know, is nothing but 0.2. D is nothing but 13.8 plus delta t is nothing but 0.3, and this is nothing but 4. And from this, see what is the number you are getting, and then try to find the value of delta v, because you also know the value of velocity from here. Come on, what is the answer that you are getting, my dear students? Yes, come on, try to figure this out. 13.8 divided by 4, put it over here and do all these calculations. I'm waiting for your answers. Come on. 3.45, I believe, but I can't keep it 3.45 because, guys, two significant digits. So round it off. Yeah, forget this 5, and this 4 should remain as it is. So it will be 3.4, I believe. This should be 3.4. Just check this out. Yeah, I think the answer given over here is slightly wrong. It cannot be 3.5, because if it is 3.45, the rounding off should be 3.4. I think the options given over here are slightly wrong. Okay, I'm just correct it right away. Yeah, 3.4 seems to be fine. Now use that same 3.4 over here. Use that same 3.4 over here, because from that you will get the value of delta V. So delta V will be 2 divided by 136 plus 3 divided by 40. The whole thing multiplied by 3.4. Just see roughly how much value are you getting. Just see approximately how much value are you getting. Yes, come on, my dear students. It's not that difficult. Yeah. Divide 2 by 136. Yes. And add it to basically 3 by 40. Yes. Add it to 3 by 40 and then multiplied by